Okay. Hello, everybody. Hello. Morning, Robert. How are you? Good morning, Samantha. How are you? I hope you're all doing well today. Pretty good. The first class, for whatever reason, wasn't so talkative this morning. But I think you guys are a little bit more talkative. So I'm not sure. Maybe it's just Tuesdays. I don't know. Could be one of those things. Morning, Hisa. How are you? Hope you're well here today. Morning, Sion. Rise and grind, indeed, indeed. That is very true. It is time for the grind, indeed. Hopefully, not too bad of a grind, though. Hey, Alex. How's it going? It's going very well, my friend. Very, very well. I'm doing great. Having a grand old time. Can't really complain. I think, how was everybody's weekend? Pretty good? Yeah, pretty good, actually. Good morning, Carissa. Yeah, I went out to Dallas last weekend, and yeah, I had a pretty good time. It was very nice to see some family out there. The weather's very nice down there, so I gotta say it was a good time for it was a good time just to kind of relax a bit, hang out with my nieces and nephews. They're very young. They're young, so get to play a lot. So uncles represent. That's right. That's how it rolls, man. Yeah, it has been a little bitter. This time for fall jacket. Fall jacket's got to come on now. We're at that stage. What do you think, guys? Should I move to Dallas in the middle of the semester? You know, I can leave you guys here. That's okay. That's it. I'm abandoning. Yeah, I'm abandoning all of you. Okay, I'm moving to Dallas in the middle of the semester. Forget it. I'm done. Donezo. Totally, totally done. No. I'll move out. I'm gonna move out. You know, in a week. Sounds like a plan. Yeah, I can stream the class from the plane, right? It's just like on the plane and just start talking. I'll take a flight every day, just to and from, just like streaming on the plane all day. That would be wild. Oh man. Nah, I wouldn't abandon you guys. That's not how I roll. Never. That's not how I roll. All right, let's get going here today. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you're having a nice weekend. All right. So, playing evil. That's right. Hey, it's how it's how we that's how I roll. Okay, always evil all the time. Okay, I even have a shirt for playing evil. Okay, let me go get my shirt. Okay, here I can show you. See if I can get my shirt. Let's go get the shirt. See, now look. All right. See, I have the shirt here. Let me see if I can put it here. Doob 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 doo. Yeah, there's my shirt. I actually wear this. It's pretty nice. Yeah, it works. Good. I told you I wasn't joking. So there you go. That is uh, that is one of my shirts. Um, I have a lot of those. That is correct. You said I was pure evil? Yup. Absolutely. I got a I got a lot of those different kind of shirts, definitely. I love wearing silly, like fun shirts like that. It's so fun. All right. I need to get All right, right. Okay. Right. I need to do my job. Let's remember my job here. Okay. Okay, let's go ahead and get started here for today. All right, so last time we talked about multiplication, we looked at applications of multiplication of fractions. All right, and we did a little bit of dividing fractions here from last time. Today, we're going to be talking more about dividing fractions. We're going to be expanding upon that topic here because we didn't get to talk a lot about it last time. Um, and so let's talk about the rule here for dividing fractions. So the rule here for dividing fractions is going to be this guy right here. So it says a over b times divided by c over d is equal to a over b times d over c. So remember, we want to convert. We don't want to divide straight across. We want to change that division into multiplication. But the consequence of doing so is to essentially flip the second fraction, aka the reciprocal of the second fraction here, c over d, becomes d over c. So we just kind of change from the numerator, change from the numerator to denominator, and from the denominator to the numerator. So d over c is the reciprocal of c over d. Okay, so we got that. Okay, now let's take a good look here at finding some of these reciprocals. All right, so as we see here, the reciprocal of 1/4 can be written as 4 over 1, which can be written as equal to 4. Okay, so that's kind of the first one there. Actually, I'll make this a tad bit bigger. There we go. Okay. All right. The reciprocal of 5 over 3 would be, say, 3 over 5. So just switching the numbers around in both places. And then the reciprocal of, say, 5 over 11 would be, say, 11 over 5. Okay. Now I want you to take a look at this first example here. out of the 3. And we're going to use that example here to find the reciprocal of another example here. So we're going to kind of fill in the blanks here in this particular case. Let's go ahead and do it. Let's say I have 8. Let's say I have 8. And I want to find the reciprocal of 8. What would the reciprocal of 8 be? 1/8. Okay, that's correct. The answer indeed is 1/8. And the reason why is because we have 8 over 1. That's another way to write 8, right? That's correct. So just like the first example says, I can write 4 over 1 as 4. So I can go in reverse as well. 4 is equal to 4 over 1. So 8 is equal to 8 over 1. And if we just reverse that around, that'll be 1/8. Now this particular fact here is very important if we want to do other examples here with whole numbers. So definitely the reciprocal is definitely going to be very useful here in terms of using the division part here in this particular instance. All right, so you guys definitely got it right here. Excellent. Okay. Now let's take a look here at another thing that we may see in some of these problems. And this is more related to how a problem is written. So if we take a look here at this problem, and I kind of copied this problem here, I said, all right, what happens if we take 4/5 divided by 3/10? Okay, so if we had this particular problem here, 4/5 divided by 3/10. Now, as you can see here in the actual book part here, and I'll zoom in just a bit. So as you can see in the problem here, this by itself makes it very confusing if you look at the problem the first time. It's sometimes you take a look at it and you're like, well, it looks like kind of 4 numbers kind of stacked on top of each other. So to reduce the amount of confusion within the problem itself, what I do is that I put parentheses around the fraction that's in the numerator and the fraction that's in the denominator. Again, we just want to see what fraction goes where, because we can rewrite it once we put in the parentheses appropriately as, and I'll go ahead and lower this down here, 4/5 divided by 3/10. And then we can go ahead and proceed to do the rest of the problem. Okay, so that's kind of the most important part here, is just being able to rewrite it in terms of maybe something that we can understand. This, I admit, is more confusing because sometimes, again, you don't want to get the numbers all jumbled up. And that gets to be a bit of a pain. All right, so without question, we want to avoid that as much as possible. Let's go ahead and figure out what 4/5 divided by 3/10 is. All right, so you guys can help me with this part for sure. Okay, so can anybody tell me, how would I rewrite 4/5 divided by 3/10? Okay, so I would not do long division to figure out the answer here. I'm going to use the rule here, Samantha. So remember, we want to change division into multiplication. And that is correct. We want to go ahead and change that to 4/5 times 10 over 3. So we're gonna flip the second fraction. KFC, Kentucky Fried Chicken. Yes. Um, finger licking good. Yeah. Nom nom nom. Now you're making me hungry here. So we're gonna man, Carissa. Um, so we're gonna flip the second fraction there. Now remember, that's the 58008. I mean, unless it's just, oh yeah, I get it. All right. And that's an old joke. Holy moly. That is a very old joke from a long time ago. Whew. All right. Man, that's a way back in the day replay. That's back to my days of having the old style calculator. All right. We gotta finish this problem eventually. All right. So if we do 4/5 times 10/3, can we reduce anything down here? What can we reduce down here? Well, you could go straight across here, but we don't want to go necessarily, so let me write that down here. Sorry. I'm going to write that down. Okay. Yeah, that's correct. So we have 4/5 times 10/3. So again, we could multiply straight across, but again, what we want to do here is, again, reduce it down before we multiply straight across so we don't have to deal with it later. So we're going to divide both, since 10 and 5 have a factor in common, so we're going to divide both of them by 5. So 5 divided by 5 is 1, and 10 divided by 5 is going to be 2. So 4 divided by 1 times 2 over 3, which will equal 8 over 3. Now we can multiply, pardon me, straight across, since there's no numbers in common between these guys. And then sometimes, yes, so they may ask you for a mixed number answer, so don't forget how to do that here. We got 3, we get 8 here. Again, that goes twice. 3 times 2, 6. Subtracted that. Here we get a remainder of 2. And so here in this particular instance, we get 2 as our whole number here. 2 is our numerator here. And 3 is our denominator. So the question here is, so you just have to find the common factor before you multiply. Correct. The key for multiplication is find that common factor. So again, one number on the numerator, one number on the denominator. So one number up top with one number on the bottom, and if they share a common factor, we can divide that common factor out. And we do that before we multiply because, in a sense, what we're doing is we are effectively reducing it down before we put it together. That way, we're dealing with smaller numbers, and it makes our job a lot easier. If we put it together before then, you would do like 4 times 10, which would be 40, and then 5 times 3, which would be 15, and then you would reduce it down. But that tends to be a little bit harder because you can end up with very large numbers, and you might not know what to divide by in order to reduce it down. So that's why we do it beforehand as opposed to doing it after the fact. Any other questions before we move on? And the number on top always goes in the numerator. Um, which part here are you talking about, Carissa? The number on top? Are you talking like 8 over 3? Or are you talking about like this 2 here? Which are what are we talking about there? Just want to be clear. Yeah, numerator is always the number on top. Denominator is the number on the bottom, if that was what you wanted to know there. Just want to be clear about what you're referring to. Oh, okay, okay. So this remainder here, this 2 here, yeah, this is the numerator here. The remainder is always the numerator. And whatever you're dividing by, this is the denominator. Yeah. So remainder is numerator here. What you get as your answer here is this is going to be your whole number. Okay. So just remember where those pieces need to go once you put together your mixed number there. Yeah. Yes, the remainder is the numerator. That's correct. So what you get as your answer will be this whole number here. So this number goes here. Right. The answer to your long division on top is actually going to be your whole number. It's actually the other way around. Yeah, so that's a good question, so you're not getting confused about what number goes where necessarily. Okay. Well, let's try another problem. I think that'll be in the cards here. Let's go ahead and give it a go. Okay. Oh, let's see what I want to do next here. Okay. So just make a note here again, only the second fraction flips after we change to multiplication. All right, that's just the basic rule of what we're working with here. All right, let's look at another problem though, because we got more problems to do. And we'll see exactly how this works out. So, all right. All right, so let's do this one here. 5 6 divided by 7 twelfths. All right. So we're going to put parentheses around this. So again, 5 6 will be on the top. 7 twelfths will be on the bottom. So if we rewrite this, we're going to have 5 sixths divided by 7 over 12. All right, so can anybody tell me how would I rewrite this? Okay, so here we get 5 sixths. All right, times 12 over 7, so that's fine. All right, excellent. So just flipping that second fraction. Okay, now let's answer the question here. Can we reduce any numbers down? Is there any numbers that have common factors between the numerator and denominator here? Just want a pair of numbers here. I want a pair of numbers. So take a look at the top and take a look at the bottom. So one number on top and one number on the bottom. What do we have? What pair of numbers can we reduce? Okay, that's correct. So yeah, 12 and 6. So that's I guess I should be a little more clear about the question I ask. It's always about what pair of numbers can we reduce here. Okay, so let's reduce by 2. Okay, you can reduce by 2. They're also divisible by 6, I agree. But I'll just show it in steps here. So you'll see here we get 3, and here we get 6. But notice here that even if you reduce by 2, you may need to do it a second time around, because here you get a 6 and you have a 3. So you'll need to do this another time. You'll divide this by 3 and you divide this by 3. So if you want to do it in smaller steps, that's perfectly fine. All right, if you want to do it in one big step and divide by 6, that's also perfectly fine. You'll end up at the same result regardless. So you have 5 over 1 times 2 over 7. Okay, and so here we get 10 over 7. And so if we actually do this out, we're going to actually get here, let's go ahead and do this out really quick. 10, sorry. So this goes in once, take the 7, get remainder 3. So our final result here is going to be 1 and 3/7. And that will be our final answer for this problem. Any questions about that? All right. Nice. Okay. All right. All right, let's do the next one here. Just doing a couple more problems here, just so maybe one more of these problems here. So let's go ahead and do this one here, 3/8 divided by 4. All right, so that'll be our next problem here on the docket. All right. Okay, so before we do this problem here, remember the key thing that you should do here before you start this problem is just to rewrite it again, okay? So we're going to rewrite this. How can I rewrite 4? What's another way to rewrite 4 again? All right, that's right. Good. So all we're going to do here is before we even change this to multiply, I'm just going to rewrite it as 4/1. So we know exactly what we're working with here, okay? We can visualize it, we can see it. Then let's go ahead and change it up. So what should this look like if we start doing our thing here? So we change it over to multiplication. What does it look like? All right. So we have 3/8 times 1/4. That's correct. Now, let's take a look at our two fractions here. Are there any numbers, any pair of numbers here, one on the numerator, one on the denominator, that have a common factor? Eight and one? Well, one goes with everything, so one doesn't unfortunately count because one goes with literally everything. So, yeah, we ignore one because of that fact. So if you were to take away the 8 and the 1, then the answer would be no. Okay, 3 doesn't go with 4, and 3 doesn't necessarily go with 8. 8 and 4? No. Okay, so this is I'm glad you brought that up here. 8 and 4 does not work here. Okay, now you're probably saying, well, why not? Because 8 and 4 are both in the denominator. We have to choose one number in the top and one number on the bottom. Okay, we cannot choose two numbers on the bottom and two numbers on the top. It has to be one on the top, one on the bottom. So one in the numerator and one in the denominator. It has to always come in that kind of pair. So although 8 and 4 would work if 8 and 4 would work, but the problem is that they're both in the denominator here. They're both on the bottom, and that's not allowed. Okay, so again, that's why I'm only looking at 3 here. 3 and 8 don't go together, and 3 and 4, they don't go together. Now, I would agree if 4 was here on the top, but it's not. Okay, so that is why 8 and 4, albeit looks good, not exactly why we choose that. No, that's no, nothing wrong. Nothing say that's nothing wrong with that, Robert, at all. It's all about just correcting those kind of mistakes, because that happens to be a very common mistake I see a lot on tests, was making that mistake that it has to be reducible all the time, but instead we want to follow the rule of one on the top and one on the bottom. So just trying to smooth out those wrinkles there. That's why you know what? To be perfectly honest, it's better if you make mistakes, because then you'll know exactly how to correct them the next time around. So so here we're going to multiply straight across, and we get 3 over 32 as our answer here for this problem. Any questions? Yes, in the previous problem, it could be done like we did in this one right below. We could do that, but we have to do a check first before we can assume that that happens. So that's the thing is, the one thing about mathematics that you always should take to the bank here is that you should never assume something will always happen every single time unless it's a consistent method. This is one of those times where that's not always going to be true. Again, we're not always going to find a number on the top to be in common with a number on the bottom. That's not necessarily true. So yeah, we want to avoid making assumptions here, because that's where we draw the mistakes. We want to react as opposed to automatically say this will always happen. So do I still do long division here, Chris asks. The answer in this case is no. We don't need to do long division to get a mixed number here. And the reason why is because 3 over 32 is already a proper fraction. So in this case here, we don't have an improper fraction like we had in the last one, where we were given 10 over 7. Instead, we have a proper fraction here, so we don't have to change that over to a mixed number at all. So again, we could get answers that look just like that. Again, a proper fraction being that the numerator number is less than the denominator number. Any other questions? Okay, great. All right, let's go ahead and try the next problem then. All right, so this time here, we're going to do division word problems. Oh yeah, everybody loves division word problems. It's the best. Okay, so let's talk about some keywords here about division word problems. And we're going to go ahead and read off this problem here, and we'll talk about what some of those things are. All right. Uh, purple. Nice. Okay, cool. All right. So Goldie, the manager of the Burnside Deli, must fill a 10-gallon kosher pickle crock with salt brine. She has only a 2/3 of a gallon container to use. How many times must she fill the 2/3 of a gallon container and empty it into the 10-gallon crock? Okay, so we gotta take 2/3 of the solution, pour it in the bucket, and repeat that process as many times as possible until we fill the bucket up. Okay, so let's take a good look here at some of the keywords here. So some of the keywords here to tell you how you know it's division here is, say, for example, says how many times, or same amount each, or what fraction. Okay, so if you see those kind of phrases in your word problem, that's a clear indication of division. Now the real question is, and this is the more important question. The more important question is, in division, order matters. Okay, so what number comes first and what number comes second? Okay, so how do we know which number comes first and what numbers come second. So I've posted this key here, so let's talk about that. So to know which numbers come first and which number comes first and which number comes second, you need to know what you are dividing the first number, okay, by what based on the context of the problem. So you want to take your dividing, okay, you want to divide a certain number, in this case, by some even amount each time down, okay? So let's take a look at our problem here, and let's see how we can determine what our first number divided by our second number is going to be. So in this case here, we have a 10-gallon bucket. Okay, we have a 10-gallon bucket here in this case. And each time we have to fill it with a 2/3 of a container here every single time. So we're just going to take that, pick it up, put it down, take that, pick it up, put it down, take that, pick it up, put it down. All right, every single time. All right, that's how it goes. All right, so what we're doing here in this particular instance is we're going ahead and that's not what I wanted. I wanted the tool here. There we go. Um, so what we have here is, let's read off this problem here, and I'll go. And it's okay. All right. So in this particular instance, if you take a look here, we're trying to fill the 10-gallon bucket. So we're taking the 10-gallon bucket, and then every time we're taking that 2/3 of a container, we're figuring out how many times we're plugging it in. Am I Canadian or American? I'm American. Red, white, and blue. How about yourself, Coolstra? I've been to Canada many times, though. Okay, so that's why 10 here is the first number, and 2/3 here is the second number, because we're dividing each one of those scoops. Again, 2/3 of a time, we're trying to figure out how many of those 2/3 scoops can fill out that 10-gallon bucket. Okay, are there any questions about that before we move forward? Okay, which part are you lost at, Samantha? Just let me know which part here so I can focus on that one. Otherwise, I can explain it again if you'd like me to. I don't got a problem with that. Well, I could start here again if you like, so that's fine. So let's imagine it this way. Instead of 2/3 of a gallon of a bucket, yeah, okay, okay. So think of it this way. Change the 2/3 of a gallon of a bucket. Change it to like a 2-gallon bucket, okay? Well, the thing is that if you have a 2-gallon bucket, you say, well, how many times do I have to pour the 2-gallon bucket into the 10-gallon bucket until the 10-gallon bucket is full? Well, I would take 10 divided by 2, and that would be 5 times that I put in 2 gallons of, say, water into a 10-gallon bucket to fill it up. Well, I'm doing the same thing here, but instead of a 2-gallon bucket, I have a 2/3 of a gallon bucket, okay, to try and fill the other 10-gallon bucket. So I'm dividing by a fraction instead of a whole number. So that's essentially kind of the thing that I'm wanting to do here, is I'm taking 10 divided by that 2/3 in that instance. Now, how we can do this is exactly the same as we did before. So to answer your question a little further there, we're going to change this 10 to 10 over 1. And then we're going to get 10 over 1 times 3 over 2. Okay, so we're going to do the same exact thing here as we did in the last problem. So remember, change the 10 to a fraction. You can certainly do that like we did in the previous problem. Not this one, but the one before it. Like changing 4 to 4 over 1, for example. Now, is there any pair of numbers here that we can reduce down? All right, 10 and 2. Okay, good. So the only number we can realistically divide by is 2. Spot on. So we get 2 divided by 2 is 1, and 10 divided by 2 is 5. So here we get 5 over 1 times 3 over 1. Should be 3. It's a bad one. So this is 15 over 1, or again 15. And that's our final answer for that, is 15 of these, 15 times we gotta fill up the container. It'll take us 15 go-arounds. Okay. Any questions about that? Okay. Now let's have you guys try. Okay, so we're gonna take a minute or two here. I want you to try letter B. All right. I want you to try letter B from this handout. It says find the number of 4/5 quart bottles that can be filled from a 120 quart cask. Okay, so we're going to get a nice whole number for this, but once you figure it out, go ahead and post your answer here in the chat. Okay. Got 35. Okay. I would look at that one again. Just make sure that you got that okay. I wonder if you added instead of multiplied there. So 150, 150. Okay. Right. I would set up the problem the same way. Okay, you did add. Okay. I was gonna say, I'm like, wait, I thought you like that's weird. Yes, I would set up the problem the same way I did kind of the last problem there. Yes. All right, 150. Okay. Let's go ahead and take a look here, see if it is 150. A lot of people put in 150 here. So let's find out if that happens to be the case. All right. All right. Okay. So for this one here, we're going to take a 120 quart cask. So we're going to take 120 and we're going to divide that by 4/5. So just like so. So again, 120 can be represented as 120 over 1. So if we rewrite this problem here, we have 120 over 1 times 5 over 4. Okay, and so here we're going to take 4. We're going to divide by 4. We'll also divide by 4 here. This becomes 30. This will be 1. So that's going to be 30 over 1 times 5 over 1, which equals 150 over 1, or exactly as you guys stated, 150. All right, so 150 is definitely the correct answer for this problem. Excellent. Nice job, everybody. Great work. Bah, in my eyes. All right. Nice job. Okay, let's look at the next example, and let's see what we need to do here. All right. So let's read this together here. At the Child Time Daycare Center, 6/7 of the total budget goes to classroom operation. If there are 18 classrooms and each receives the same amount of money, what fraction of the operating budget does each classroom receive? Okay. So, now this one you have to be a little bit careful about. Well, let's take a look at what we want to look at. Now, we know we're doing division here. It says what fraction of the operating budget does each classroom receive? Now, each classroom here is receiving the same amount of money. All right, each one will receive the same amount of money, and it'll be a fraction of the 6/7 that we have here. So in this case, we're taking every one of the classrooms here, all 18 classrooms, and we're dividing it up evenly. So the question really becomes is, how should I set up this problem? What should it look like? What should this problem look like in terms of a division problem? The 6/7 divided by 18. Okay, that is correct. Very good. That's right. Now let's talk about why. Of course, because in this case, you're like saying, well, why is it not 18 divided by 6 over 7? Why is it 6/7 divided by 18? Well, let's discuss why that is. In this particular instance here, if we look at the wording of the problem, the wording of the problem states that 18 classrooms each receive the same amount of money. So we're taking this money here, whatever the amount is, and we're splitting it up 18 ways between each of the classrooms. Okay, so it's like basically instead of 6/7, imagine if I had, $200 and I'm splitting that up 18 ways. Okay, I'm splitting it between 18 people. I would take that 200 and I would divide by 18 so that each person would get an equal amount of the $200. Well, I'm not doing anything different here. Instead of having a knowing amount of money, um, instead I have a fractional representation of that money. But the process here is exactly the same. So I'm still going to have 6/7, and I'm still going to go ahead and divide by 18 for that reason. Okay. So now let's go ahead and see what we get here. So we get 6/7 divided by 18. So we get 6/7 times 1 over 18. All right. And so we're going to go ahead and then see what we get here. So we'll divide by 6. So we get 1, we get 3. So we got 1/7 times 1/3. And so our final answer here is going to be 1/21. So 1/21 of the budget will be spent on each individual classroom appropriately. Any questions about that? Okay, no. Okay. Okay, if there are no questions then we will now move forward here with the next section. So let's talk about the next section here. Now I didn't get too far in this next section, but I did get far enough where we could talk about at least the main points here in this particular section. So this section here is talking about multiplying and dividing with mixed numbers. Now there's only one key here in talking about mixed numbers, at least in this context, and the key is very simple. We're going to convert all mixed numbers into improper fractions, multiply or divide, and then convert the answer back into a mixed number if it's necessary. Okay, so that's essentially what we're going to do here for every single one of these problems, is to do exactly that. Sorry, that light's kind of in my eyes here. All right. All right, so let's go ahead and do some examples here, and let's see how we can attack these problems. All right. Okay. Yeah, we're not forget that. So let's do some multiplication here first. Let's do this first one here: 3 and 5/8 and 4 and 4/5. Yes, this is section 2.8. That's correct. Okay, so what we're going to do first is we're going to go ahead and change. Will we get to section 3.0 today? Maybe, maybe not. Probably not today. Probably for more next time. But we will get to section 3.0 definitely next time. So chapter 2 and 3 will go together. Uh, so yeah, the next section here is chapter 3. We're going to talk about adding and subtracting fractions. So that requires a lot of time to kind of go over. So. All right. So if you want to know like your sections for like homework there, sections 2.7, 2.7 and 2.8 today will be I wanted to get through section 3.1 here today in my first class, but I wasn't able to. So that'll be those are the two sections you should probably be working on if you're trying to keep pace. So all right, let's talk about remember here how to convert mixed numbers into improper fractions. So we're going to take our whole number here of 3. We're going to multiply it by 8. And we'll add the numerator here, which is 5. And we're going to put that all in the denominator of 8. So this is basically 24 plus 5 all over 8. And so here we get 29 over 8. All right. Now, 4 and 4/5 here is going to be a little different. We get 4 times, not any different here, 4 times 5 plus the numerator of 4 again. Put that all over 5. So we get 20 plus 4 over 5. All right, so here we get 24 over 5. Now all we want to do is go ahead and multiply it together. So you get 29 over 8 times 24 over 5. So we want to go ahead here and see if we can reduce. We can certainly reduce here. Notice that 24 and 8 go together. So we're going to divide by 8. So here we get 3. And here we get 1. So we get 29 over 1 times 3 over 5. So unfortunately, we don't have a pair of numbers that can reduce down anymore. So 5 certainly doesn't go into 29. So we're going to multiply straight across here. So we get 87. And we get 5 here on the bottom. So now what they may ask you to do is they may ask you to put this back into a mixed number form once you're ready. So some of the problems will ask you to just put your answer in mixed number form. So again, to do that, we're just going to do 87 divided by 5. So 5 goes into 8 once. So you have 37. So 5 goes into 37 7 times. So we have 35. So we have a remainder 2. So our final result here will be 17 and 2/5. Why didn't I flip the 24 and 5? Because this was a straight multiplication problem. That was from the very beginning. If it was division, I would flip the 24 and 5. But this problem here was just straight multiplication, so that's why I didn't flip it. Flipping is only applicable to a division, so any other questions about this problem? Okay, let's go ahead and do another problem then. Let's try a division problem here. Let's try 8 divided by 3 and 3/5. Okay, so here in this case, we'll need to do, I haven't erased it yet, trust me, haven't erased it. So remember we can write 8 as 8 over 1, so that'll be our first thing to do. And remember we want to also rewrite 3 and 3/5 as an improper fraction. So 3 times 5 is 15, plus 3 is 18, get 18 over 5. Okay, again what we get here is we get 8 over 1 times 5 over 18. All right. Now, are there any numbers that we can reduce? Okay, I agree. What number can we divide by then? No? I think 8 and 18 definitely work. What number can we divide by between 8 and 18? Divide on the top, divide on the bottom here. Remember, it doesn't have to necessarily be the whole thing, as long as it shares a common factor. 2, that's correct. Good. So we're going to divide by 2 here, and we'll also divide by 2 here. So 8 divided by 2 is 4, and this is 9. Okay, so we have 4 over 1 times 5 over 9, which is 20 over 9. What did I do with the whole number 3? Oh, well, I made 3 and 3/5 into an improper fraction, so I did this. So I did 3, that's this 3, times 5, plus this guy, this 3, all over 5. That's what I did there, and then I added together 8, you got 15 plus 3, which is 18 over 5. Any questions about that? Don't forget to convert 20 over 9 into a mixed number. If you want to convert that into a mixed number, that's going to be 2 and 2/9. So all right. Any questions about that? Where did the 18 come from? The 18 came from here, right there. When we converted 3 and 3/5 into 18 over 5. That's where the 18 came from. Because then we just flipped it around because we had it divided by 18 over 5. So we flipped it around to 5 over 18. So again, remember, every time you're doing these mixed numbers, you're converting it into improper fractions every single time. So make sure you know how to convert mixed numbers into improper fractions before you go ahead and do the rest of the problem. Any other questions? No? Okay. All right. Let's go ahead and do one more here. All right. So let's practice just one more time. let's see here. All right. Okay, that's a good idea. Let's do, you know what, I gotta make up my own. Yeah, let's make up my own. All right, let's do this one here. How about 6 7/9 divided by 3 2/5? Okay, so 6 7/9 divided by 3 2/5. Okay, so can anybody tell me here, what would 6 7/9 be as an improper fraction? What would that be as an improper fraction? Anybody? 6 7/9? 61 over 9 and 17 over 5. Very good. That's right. Right. That is correct. So again, 6 times 9 plus 7 over 9. And 3 times 5 plus 2 over 5. So what we're going to do next is just go ahead and take 61 over 9 times 5 over 17. All right. Do we have anything that we can divide out? Anything that's in common here between a number in the numerator and the number in the denominator? No. Okay, I would agree with that. The answer is no. All right, so we're going to multiply straight across here. It looks like it's close, but 61 and 17 have nothing to do with each other. All right, so we're going to just type it in here. We can use our calculator for this one here. So you get 305 up top and 153 on the bottom. Again, I fully expect you to use your calculator for this last bit. Okay. And if we do this out here, you can do the long division here if you like. You could do 153 here. And you put 305 here. And we'll figure out how many times that goes in. So 305 divided by 153 goes in one time. So this will be 153. You'll do this out here. This will actually end up to be 152. So that's our remainder. So our final answer here is 152 over 153. And that's going to be our answer for this problem. Any questions? No? Okay. Very good. All right. Good stuff. Okay. So that is where I ended off here for the first class, and I think this is a good time to end off here as well. Um, Next time, we're going to go ahead and do a couple of application problems here from this section, okay? And then once we're done with those, we're going to go ahead and go right into chapter 3, talking about adding and subtracting fractions. So we're going to talk about those in a lot more detail. All right. Great job, everybody, here today. Wonderful work. All right. So that will take care of it for today. I want to thank everybody very much for coming out to the stream. And again, hopefully we learned a little bit more here today, but we're well on our way. So we're in good shape. So far, so good. All right. Thanks again, everybody. If there are no more questions, okay. Or again, if you do have questions, I'll have office hours in about half an hour. So then you can email me and I can be online if you need me. Okay. Take care, everyone. We will see you all on Thursday. Have a wonderful day. You have some poggers as well. All right. Have a great one, everyone. Take care. All right. Bye.